No.
Hi, welcome back. My name is John. If you didn't join us last time, well, welcome to the AI course. Today we're going to be talking more about Python programming and getting into math and Boolean operations. So today we're going to go over all of the basic mathematical operations you could do in Python, those being addition, subtraction, multiplication, division, and a few more we're going to talk about more in the video, but we're also going to get into Booleans and Boolean math, quote unquote. If you never heard of Booleans before, it's any value that could be either 1 or 0, true or false, on or off. And if you know anything about programming or anything about computers, everything in a computer is either zeros or ones, hence the name binary. These are going to be Booleans that you use inside of a program. Computers run on them. The whole essence of Booleans kind of carries throughout the entirety of just programming in general. So this is going to be a super important video to pay attention to if you've never seen Booleans before. I'm going to give you my take on Booleans. My take is a little different than the way I've seen it be taught before, but my take is essentially we treat it like math with a couple of rules involved, but it might help you understand it in the future, especially with comparison operators, especially with equality operators, and just joining a bunch of things together. It's kind of the whole idea behind it is, well, it's got to be math. And it's gotta be understandable, and we gotta kind of wrap our head around it in some way, especially if you've never seen it. Booleans might be a little weird. It's one general comment that I see from new programmers is that they don't necessarily understand too much about how Booleans work and the importance of them, and that kind of hurts them in the future. So if you've never seen them before, or if you feel like you're not as strong as you can be with Booleans, definitely pay attention today, as we're going to be getting into them deeply. If you at any point during this video feel like you need to give me any feedback in the way I'm teaching this course, I'm greatly appreciative of that. Feel free to leave that in the comment section down below. And also, if you want to help boost this video in the YouTube algorithm, don't forget to leave a like. You know, if you think about it, we're actually executing Python code every single time you like or dislike a video, only because the Python algorithm is written in Python. And if you think about it, it's kind of what this whole course is about. So maybe we will at some point look at the YouTube algorithm, or at least a like YouTube algorithm, some algorithm that's like the YouTube algorithm, or just like a sorting, rating, recommendation algorithms. They're pretty interesting, and they do have to do with AI, only because you gotta know what people like, and you gotta be able to get them to watch your videos, and that's all to do with AI, at least falls in that subfield of AI, so that could be something potentially we do in the future. So maybe if that also interests you, definitely let me know. But anyways, I hope you enjoy this video. Okay, moving on with today, we're going to create a new Jupyter Notebook. So if you're following along, if you're following along with the course at home, then this is as simple as either creating a new Python file or creating an Jupyter Notebook like I am showing you guys today. If it's needed, you can go down into the description and ask me how to actually create these and how to actually set this up on your computer. If enough of you actually said that you need help, I will be more than happy to make a little quick demonstration on how to do that. But nevertheless, let's get started. Before we talk about Booleans, let's actually talk about just math in general, right? Because math, you kind of need to know about math before we could even talk about Booleans, because Booleans have their own version of math. But math should be what I would say a clear just review for everybody, besides maybe one or two. So let's get started. So let's say I have some number, I'm just going to call it y, is equal to something. Let's create x. I'm just going to say x is equal to 5, right? And then let's go back down to y and say y is equal to x plus 5. If you had to guess what y would be, y is clearly going to be 10, right? If I have 5, that 5 is going to replace this x when the program sees x, and then it's going to add it to 5, right? It's obviously, I'm reiterating that a little too hard, but the important part is that you could see that we have x being set to the value of 5, that x is then going to get replaced with the value of 5 when the program runs this line, and then y is going to be set to the value of 5 plus 5, which is just 10. Why am I doing like an in-depth like explanation of how that actually like is getting run? Well, what I'm trying to get you to understand is that this x is like a temporary variable, and that temporary variable is going to have some sort of value. And that value is going to be replaced when this expression is actually getting run by the program. That might be a little confusing, so if that is, I want you to stop even considering what I'm saying when I say that, because we'll go more into that later in this course. But just understand that if you take a variable with some value, using that variable throughout your program will clearly use the value of whatever that variable is going to have. So let's do some subtraction. So let's say y is now equal to 12 minus x. If we print y, we should see that y is equal to 7. So there you go, that's subtraction. If we have y and we set it to x times 3 and then print y, we should see y is now equal to 15, right? 5 times 3 is equal to 15. And then the last and final one that everybody should be familiar with is if I have y, and this might look a little weird, so I'm going to explain this a little bit more. But if I have y and I divide by some number, let's say it's 7, then I could just use the value being stored into y at this point, put that value back into an equation, right? So really what I'm trying to show here is, right, let's just print y here. So we're going to have 15, right? So this expression is going to get replaced with 15 divided by 7, right? And where did I get this 15 from? Really, I'm getting this 15 from right here. We're viewing the actual value of y at that point, and then that value is going to get plugged in here. Notice how I haven't actually taken a look at this, because right away we could kind of see what's going on here, right? Obviously our y is getting replaced with 15 and divided by 7, but why is it the case that this is taking priority over setting it equal to y, right? For a lot of people, this might look really weird that we're doing this, that we're even allowed to do this. So I want to go into a little bit more depth of why this is allowed. In programming, you have this thing, it's kind of like order of operations. If you think about order of operations, you have parentheses, you have exponents, and then you have like times and divide, and then you have like add and subtract, right? These are like the normal order of operations that you would have in just math, right? PEMDAS. Well, programming has its own order of operations that it's going to use when executing a program, right? If you start to think of programming as sort of like this weird version of math, it'll probably make a little bit more sense especially if you're used to something like this, only because this program is going to see this operation first, execute this operation, get the value, and then send that value back into y, right? That's why we can do this, right? Because this y is being used independently from this expression right here, right? The program separates it into two things and runs this one first, and then sets whatever is the value of this value is from here into there, right? It's kind of like an order of operations, but it's more of along the lines of these are kind of like two separate pieces of code, in the sense that this is just getting a value, and then this is just setting the value at that place in the computer program. Let me kind of show that with another example. So, okay, let's talk about floor division and remainders. So let's say y is equal to 13, and let's just say slices of pizza. Now let's say x is equal to 5. I know we already have it up there, but let's just bring it back down here, and let's say people. So if we want to split up to each of those people, at least in whole slices, how many slices can we give to each person? Well, you could represent that simply with just saying, well, what's y? Floor divided by 5. And you could think of floor division as some sort of way to say, well, what is y divided by 5, right? I'm going to replace this with x. But you can see that that's 2.6. And really the difference between these two is just, well, you have this little extra piece right here. Let's just get rid of that. And just look at the whole number, right? Because if we said that we don't want to split up any of our slices of pizza, we're not going to split them up. We're just going to keep whatever whole number we have there and just say, you know, there's all of these extra slices. Let's just leave them. And why would we really care about this? Well, let's just demonstrate one property about floor division that personally I think is pretty cool. And that's that it gives you back an integer, right? If you're using, obviously you could convert from integer to anything else, but this is really simple because it lets you count something, right? We said integers are meant for counting, or at least they're really useful for counting. And here you could see that if we floor divide, right, if we're trying to count the number of slices that each person can have without divvying up the extra slices to anybody, then that value is just going to be some sort of counting number, right? We're counting whole slices that we could give to people, right? And we said that that's equal to 2. Okay, what is the remainder? Like, what is this 0.6, right? That's kind of what you consider remainder in division. We don't have a whole number here, but we have this little 0.6, right? If you remember back from like the elementary school or middle school, you used to like put that little hat over and then like do out the long division, right? These numbers were bigger, especially. And you have that little piece for the remainder. Well, what is that remainder, at least with whole number, right? Because if these were two really large numbers, obviously you could probably do this math in your head, but what would be that remainder in like an actual everyday situation? Well, let's take a look. Okay, so if we see that y floor divided by x is 2, well then we could just say, okay, well, what is 2 times x subtracted from y? Well, that's going to give us 3, right? It's pretty simple, right? Because 2 times x, we said x is equal to 5, and 2 is just 10. 2 times 2 is just 10, right? Well, that's if we gave each person 2 slices, right? Like we had previously. That's this number. Well, now we can see that if we did that and divvied up the slices how we said we were, we'd have 3 slices left in the box, right? We could say this is how many slices are left in the box. Now, why am I going through this long pain of showing that? Well, we could also quickly see this by just saying, okay, what is x modulus y? What is the remainder of x when divided by, what is the remainder of this division right here when I take y and divide it by x? What's that remainder part? What is this portion in a whole number form, right? And that's going to give us the same response as if we did this, right? I'm going to comment this out and just demonstrate that those numbers don't change even if I'm running this afterwards. So this is basically the essence of math. You have a couple more things, like if I have x and I want to raise it to some, let's say 2, right? X is equal to 5. That's going to give us 25. Well, what is that really doing? This is just an exponent. If you're not familiar with exponents, it's just saying x times x. And if this was 3, then it would be x times x times x, right? Let's just show that real quick. Okay, so let's create a new markdown and just say booleans. Now, what is a boolean again? We kind of said it is just a question that you're posing to the computer, right? Let's say I have x is equal to 6. y is equal to 4 is x, let's just show how we could use this now with math, is x minus y greater than 3? And the answer should be false. But if I say greater than 1, the answer should be true, right? One helpful way is this difference greater than 0, right? That really is just asking, is x greater than y, if you think about it, right? Is x greater than y, right? Which, if x minus y is greater than 0, then that should also be true, right? Well, that's a little bit of variable manipulation. We're not going to get too much into there because this isn't really a math course, algebra course, whatever you want to call it. But what this is going to try to show you today is that, okay, well, let's just set that into it. Is x less than y? We're going to pose that little question. You could feel free to shorten that little variable. Is x lt, I'm just going to shorten it to less than y, right? Is x less than y? X less than y. Where did I get this from? This little less than sign is going to check to see if this is less than that. That's going to create us a little Boolean expression. And then that's going to have some sort of truth value, right? That's going to give us either true or false, right? One of those two, right? I could print that, and no matter which way I change these variables, right? No matter which way I change these variables, that's either going to be true or false. Okay, so let's come up with another Boolean expression. Let's say, is x greater than y? And then let's just show that. So x greater than y. It's another Boolean expression. Let's just print that, is x greater than y. Let's print both of these. So I'm just going to print that and print that. So you can see that this one is false and this one is true. Okay, well, why do I care? Let's come up with a third expression and then start using these for some cool little demonstrations. Okay, well, let's say, is x times y, is xy not 0? And that's going to be, well, just x times y not equal to 0. Why? Well, sometimes you might want to know if two things are equal to 0. Probably really not. I'm just trying to demonstrate some sort of Boolean, right? We're taking some sort of math expression, comparing the value coming from that math expression to another value, right? This right here is does not equal, right? So if we set this equal to 0 and then printed, let's just print this too, print is xy not equal to 0, you would see that that is false, right? Because if I take 6, multiply it by 0, that's going to become 0, and then we're checking to see if 0 doesn't equal 0, which is not true, right? 0 is obviously equal to 0. So if I reverse this and say, well, let's come up with another one, is xy equal to 0, and that's just going to equal, maybe you could kind of see where this is going, but instead of not equal, we're going to have equals 0, right? Super important that we have two equal signs, right? This is checking, does it equal, right? So that's checking if this left-hand side, does left-hand side equal right-hand side, right? And I could even say that up here, right? Does, hold on, let me get rid of this. And does left-hand side not equal right-hand side? Okay, well, like to think of all expressions that use math or Booleans, right? This is kind of like a Boolean operator. We'll talk a little bit more about operators. You could just think of an operator like plus, minus, divides, exponents, right? These are all things that are modifying what we're dealing with. I think we might have talked about it a little bit last time. But you could think of these operators as taking a left-hand side and a right-hand side and producing some sort of value, right? Let's just write that down because that's also super important, right? Operators have a left-hand side, a right-hand side, and produce some sort of value. This is kind of to do with math in general. We could kind of see that just from all of these, right? We have a left-hand side here, a right-hand side. We're producing some sort of value, and then we're setting that equal to y. We're doing the same thing here, right? This is taking some sort of value from this multiplication, taking 0, performing some sort of operation on these two, right? Checking if they're not equal to each other, and storing the result into this, right? Which we said, since this is a Boolean operator right here, that's going to either be true or false, right? So let's print is xy equal to 0, and let's run that. Well, you could see that if we have this one equal to false, then this one should obviously equal true. This is kind of important to see, and it might make sense immediately, right? If we have something that's not equal being false, then if they're equal to each other, that should, and then something checking if they're equal to each other, if one of them's false, the other one should always have the opposite value, right? You could see that if one of them isn't equal, the other one should be equal, right? Because these are checking the same idea, right? This is checking the opposite of this, right? Because something can only be true or something can only be false, right? You have two possibilities. If I check the two opposite things of each other, then what I'm essentially doing is flip-flopping the output of this expression right here, right? These two are what I like to call opposites, or more mathy term, negations. Let's forget about the mathy term for now, and let's just consider them to be the complete opposite of each other, right? You would expect that if I said something to you that was meaning one thing, that the complete opposite of what I said would mean the complete opposite of what I'm trying to say, right? If I said that I am 21 years old, the opposite of that is saying that I am not 21 years old, right? If I said that my favorite color is blue, then the complete opposite of what I'm saying is my favorite color is not blue. So really what I want you to see here is that this whole opposite thing, right? This whole opposite idea is just taking one thing and producing the opposite of that, right? And how are we doing that? Well, really, it's coming from this thing right here. But let's actually show it how we would do that, right? Because that's also something that's super important, right? Here, we're coming up with some sort of Boolean expression. Here, we're checking equality or not equality, not equal. Here, we're just checking equal, right? Well, I could come up with the same thing here, right? Let's take this and bring it back down here, right? Here, we're just going to use the word not, right? So you might be starting to see some sort of pattern here. If you can, that's beautiful. But let's just put this in some sort of parentheses, right? And let's think of how we're going to produce the same thing that we have here, right? Let's just throw the word not in front of this, right? And then run that. Well, let's just print is xy not 0. You can see that that is going to have the same value as this one up here, right? Why is that the case, you might ask? Well, because the opposite of what we had here is just this with this not thing thrown in front of it. Oh, wait a second. that's kind of interesting. If you've never seen stuff like this, this little like manipulation that we're doing with this word not, you could use this to say, okay, here you could see that we have two things, right? Is x less than y, or is x greater than y? Okay, well, what if I said, are they equal? Are equal? Are x, y equal? X, y equal? Well, and I know there's a lot of stuff here, so I'm going to try to like dial this back a little bit. Well, if x is greater than y and x is less than y, well then, or if x is less than y, they're clearly not equal. So let's just say not equal. So let's just take those two Boolean expressions that we have up here, right? Is x greater than y, or is x less than y? So you could already see, are x and y not equal? Let's print are x and y not equal, and you could say that those are true, right? Clearly these two should not be equal by this statement right here. Well, because 6 is 6 and 0 is 0. 0 and 6 do not equal each other. Well, what if we change this to 6 and run this? Well, you could see that that turns to false, right? Because, okay, 6 is not greater than 6, and it's not less than 6, which means that even though we said and, even though we said or, what am I saying? Sorry, getting ahead of myself. Even though we said, are either of these true, right? Is this one true? Is this one true, right? Print that expression. Well, neither of these were true, so this value never changed. Well, okay, let's discover something a little bit about or. And I'm trying to do this the best way I can for people who've never seen Boolean stuff. Well, this value or this value is kind of like what I said before, right? If we had a math with a minimum of 0 and a max of 1, then you could consider this to be 1 or 0. 1, 0, right? Because let's forget about what this is actually valued at. 1 or 0 plus 1 or 0, right? And let's say they're both equal to 1. Well, in this math language, we kind of said that in Boolean math, I'll put that in Boolean math, we have a min equal to 0 and a max equal to that, which means that if we have some value plus another value, like let's say 1 plus 1, that's going to equal 1. And if we have 1 plus 0, that's also going to equal 1. You can kind of see that, right? If we have 1 plus 1 in this language, right, where anything has to be between 0 and 1, then that's always going to be 1, and that should also be 1 because we can't have anything more than 1 or less than 0. Okay, what about 0 plus 0? That should also equal 0 because we said that you can't have anything less than 0, and 0 plus itself is just also 0, right? We're not really changing anything else. But I would say the hardest thing to understand right off the bat is that if you have 1 plus 1, that's equal to 1. That's a little weird to look at, right? But this is just Boolean math, right? Boolean math says something could be true or false, right? Something could be true or false, right? True or false. And if you have something that's true and you add it to something that's true, that's going to end up to be true as well. That's kind of what our or expression is doing here, right? I like to think of or as like Boolean plus. Boolean plus. And then you could kind of assume, okay, well, what does and mean? Let me just move this. What is and? Well, and you could think of Boolean times, right? Let's just copy this expression and show and you can assume that this will always be false, because something to be greater than something and something to be less than something is impossible. It just doesn't make sense. If I have 2, 2 is greater than 1, but it's not less than 1. That's impossible, right? So we should always see print r. I'm just going to say r, x, and y, gt, lt. Let's run that. And you're going to see that that's false. And there's really no value that I could punch in here. Even if they're the same, right, it just doesn't make sense. Punch that in, right? We're never going to get this to be true. And the reason for that is only one of these can be true at one time, based on the fact that one of them is saying is x less than the other one. One of them saying is it greater than. Well, how do we modify this expression so that it could be r, x, and y equal? Now, I'm actually going to copy this, paste that down here, and I'm going to let you guys at home, r, x, and y equal. I'm going to let you guys take a crack at what we have so far, right? We should what and does. It's Boolean times, and really what I wanted to show you with that before we actually let you guys try this one on your own is, well, if I have this and, right, then that's just taking this, like let's say it's 1 or 0, and multiplying it by 1 or 0. So in order for this to actually be true, I need to have something to be true and another thing to be true, if that makes sense, right? So if I have this equal to 1, right? So if I have something that's equal to true and I multiply it with something that's also true, I should get something that's also equal to true, right? 1 times 1 is equal to 1, the identity property. But if we have 1 times 0, that's going to equal 0. 0 times 0 is equal to 0. And 0 times 1 is also equal to 0, right? These two are basically the same, so I'm just going to get rid of this. But really what I want you to see here is now we only have something being true if those two, like here we had most of the time, if something's true, then the whole thing is true, right? You just needed one of these values to be equal to 1 in order for this to be equal to 1. Here, you need both of them equal to 1 in order for this to equal to 1, right? So what I want you to do is manipulate this expression. I'll give you a little hint. We're going to be using this not. We're going to be using this not to manipulate this expression to print whether or not these two are equal. So I'll give you guys a quick second, pause the video here, and try this out if you're following along. Okay, so if you're following along and if you have some sort of like really good intuition of what we're doing here, I never did when I was in programming. I'm really slow at picking this stuff up, so that's why I'm going super slow, just to let everybody kind of see what we're doing here. But you could already see that, okay, is x greater than y? Well, we said that that's only going to be the case if x is not equal to y. And we said that x is only going to be less than y if x and y are not equal. Okay. Well, if both of these are only going to be true if x and y are not equal, well then if I say not is x greater than y and not is x less than y, well, shouldn't that be the same as saying is x equal to y, right? Isn't this is basically saying, okay, not x greater than y and not x less than y, right? That's kind of what this is saying here, right? So
if I print this out and they're not equal to each other, I should see that this should be false, right? Because x being equal to 5 is not equal to 6. But let's do something quick here and change that. If we come back down here, we should see that this is true, right? Because x, right, let's just replace this with our expression, right? We're going to have x is going to be equal to 6, and y is equal to 6, right? So you could see that, let me just put not here, right? Not is going to come here, and then not x less than 6, well that's going to say 6, and y is also 6, right, from up here. Then, okay, not 6 greater than 6. Well, 6 obviously isn't greater than 6. So this inner expression, right, let's break this down even more. And I'm going to go to the next line. Well, that's really saying, okay, not 0, not 0, right? Because 6 is not greater than 6. So this is going to become false, like we said up here, right? 0 and false are basically the same thing. And then this not 6 less than 6, right? And not 0, because this is obviously not true as well. Okay, well, let's do a little bit more, right? I'm trying to show the whole process of how this expression is getting pulled out, right? So if I said not 0, right, well, if something is not false, then it's obviously true. and if something is not false, then it's obviously not false, right? True. And then what you're going to see here is that, okay, well, 1 times 1 is equal to 1, right? This is what we got down here. And I know that because, okay, well, we said before that this and is kind of just like multiplication. And these expressions both came out to be true, right? Because we put a not in front of this, right? X is obviously not greater than 6. 6 is not obviously greater than 6. And then 6 is obviously not less than 6, right? Doesn't make sense. So both of these are going to end up to be true. And then we put this little and thing, which is just multiplying. Well, is this thing true times this thing true? Which gave us true, right? This might be super basic, super intuitive for a lot of people, but for me it wasn't. So I want to go over this really quickly and just kind of show where these numbers are coming from. Because Boolean math is something that people don't really learn, especially if you're younger. This might not make a whole lot of sense, but I want you to understand and see where these things are coming from. Today, just to reiterate what we did a lot of math, just as like basic precursor stuff, and then we went over some Boolean expressions, right? We have this little less than operator sign, this little greater than operator sign. We introduced these two new signs here, right? We have the not equal to and the is equal to. We kind of joined together some math stuff from above with these operators, and then we introduced the or, the and then the not, right? The not, right? We have the not up here, so I'm gonna get rid of this because I didn't see that. But we introduced the or, and the not, right? So really, these are what are going to make up all Boolean expressions, right? Is something not what it is, right? We could join, right? This is basically flipping the value, right? Not the case is just flipping the value, right? And really, if I have 0, well, this is just taking in some sort of input. 0 or 1, let's say, is 0 or 1, right? Not 0 or 1. That's just saying, okay, well, if not 0 is equal to 1, not 1 is equal to 0, right? And let me just say not true. Not true should be false, and not false should be true, right? That makes sense with just basic English. And we're going to stop here because I don't want to spend any more time doing anything else. But what I want you guys to start to see is that we could join together little comparison operations, right? What is a comparison operation? It's just taking two values and using some sort of comparator operation like OR, right? Is this thing true or is this thing true? Is this thing equal to this thing over here, right? Is this thing less than this thing over here? And are these two things not equal, right? If this is 6 and this is 5, is 6 not equal to 5? Yes. Is 6 not equal to 6? No. And you could kind of join these together to come up with a whole lot of different things. On that note, we're going to stop here and stay tuned for episode 3. Thank you for watching.
Should we